All right, we are going to do some logarithmic functions, and we're going to talk about the inverse and domain, all that fun stuff that we keep talking about on like everything. So the inverse of any exponential, so something like 2 to the x. The inverse, now we learned last week, about the log, the like Joule method, and that's what the inverse is of an exponential. Like the inverse of an exponential would be log, the base is a of x. So if I wanted to find out if I have f of x equals 2 to the x, which is the exponential, the inverse would be log base 2 of x. Log base 2 of x. Now you can, type this into Desmos, but if you remember, any inverse, it flips over the y equals x line, which is this line that goes through 0, 0, goes up 1 over 1, up 1 over 1. So, and if you remember, your domain becomes your range becomes your domain. So this graph actually looks like this. So this has a domain now of 0, the asymptote now right here, there is a vertical asymptote for logs of 0, and you can't be 0 because if you try to put that in your calculator, you can't take the log of 0. So it's from 0 to infinity. The range, well, that was the domain of this. Remember, this was the domain, the domain was negative infinity to infinity. Now that's the range, negative infinity to infinity. And so we're going to start talking about just that, finding domain again. We're going back to all this, but there's this, again, this main idea is there's now this asymptote right here, and you can never be 0. You cannot be 0. It's an open at 0. So right here, find the domain of these. You can, again, punch this into Desmos, and I'll do that for a couple of them. But what you're essentially saying is this right here, whatever you're taking the log of, has to be bigger than 0. It cannot equal 0. It has to be bigger than, so x minus 1 has to be greater than 0. So that's easy to solve for. X is greater than 1. So your domain would be from 1 to infinity. Same thing for this one, no matter what the base is. This is, remember, this is a base 10 when I don't write it. So take whatever is here, make it greater than 0, and then just solve. 7x is greater than negative 3. Divide by 7. X is greater than negative 3/7. I didn't divide by a negative, so I didn't flip it. So my domain would be from negative 3/7 to infinity. Even this one. X squared plus 4, when is it greater than 0? Well, I mean, there is no number. Think about it right now. You could minus 4, but take a square root, but that doesn't make sense. This is always going to be, always going to be 0. I mean, put a, negative number in. When negative 1 squared, that's going to be greater than 0. So you don't have imaginaries. You're not graphing imaginary. This is always greater than 0. So this would be from negative infinity to infinity. And again, if you're ever unsure, just to show you this one right here, go to Desmos. And I was playing with a few before. The function, you have to go to function and then down to, I believe, calculus. And there's your logs. There's the ln, but you can actually just type in ln. But ln of x squared plus 4. And you can, zoom out and see, hey, there's not really, the domain just keeps going on and on and on and on. I'm at negative 1,000 right now, and I still have a red picture. So, oops. Now I've zoomed over a little bit too much. But you can always double check by using Desmos. So domain is very simple. Just take whatever is next to the ln or the log and make it greater than 0 and solve. And so same things here. Now, algebraically speaking, for these two, we have done this before. We did a whole section on this. I'm actually just going to put both of these here at the same time. This one, you are working with a squared, which means that you're supposed to do a sign test on the number line. And if you don't remember how to do the sign test, I'm just going to show you algebraically, analytically, how to do this. You would factor this side to be x plus 2x minus 2. And then you would plot those zeros at -2 and 2, and you would sign test each one of these zones. And if you don't remember what that means, you just pick a number. And by the way, there's just 3 zones, so it's always going to go plus, minus, plus, or minus, plus, minus. It just flip-flops like that. But I'm going to pick something in the middle. I'm going to pick 0. So if I pick 0 for x, that would be positive times a negative, which is negative, which means that this side and this side have to be positive. But then answer the question, which one is greater than 0? And that would be from here and here. You can't equal 2 or -2 because that would make it 0. We're not allowed to be that. So my domain would be from -infinity to -2, united with 2 to infinity. So that's one way of doing it. Again, please go over to Mr. Desmos and let's just take a look at what this visually looks like. So if I go to type in, let's see, ln of x squared minus 4. And now this is the picture they give me. So if I'm asking you for domain, you'd say, yeah, from -infinity. Well, it looks like there's something going on here. It looks like there's some asymptote here. And it appears to be at -2. Again, it's going to look like it's touching -2, but if you're like dragging a point like I am, it actually never touches -2. It's very close. Actually, it gets to a point on the Desmos where it won't even find a point anymore for you, and you're just going to have to know. So it goes from -infinity to -2, then it jumps over to 2 to infinity. And that's exactly what we did by doing the sign test. And I'm just going to put the next one in here while I'm going to put the letter E inside. This is the log of x minus 7 over x plus 8. And let's see. Ooh, there it is. And so it looks like, again, it's getting very close to, see, when I click and drag, it starts to go away after a certain point. But it looks like it's getting very close to -8. And then over here, it looks like it has an asymptote at 7. And that would make sense with this right here, this fraction. You would have a 0 on top, and undefined at -8 on the bottom, and a 7 would make it a 0 on top. But again, you could always do it analytically to find the domain, which would be do a little sign test, plot the 0 on top, which is 7, and plot the -8, which is undefined on the bottom. And then do a sign test. So I'm going to pick x to be 0. If I plug 0 on top, I would have negative. If I plug 0 on the bottom, I'd have positive. Negative divided by a positive is negative. And then these two would be positive. And then answer the question, when are you greater than 0? And that would be from here to here, which is exactly what we had in the picture. So my domain is from -infinity to -8, and then 7 to infinity. So easy stuff for domain. Again, what am I doing every single time? Greater than 0, greater than 0, greater than 0. Everything has to be greater than 0. All right. Some more lovely graphing and understanding. The inverse of e to the x. Well, e to the x is just like a to the x, 2 to the x, 3 to the x, except it's a decimal that goes on forever and ever. But if you want to undo an e, you ln it. So the inverse would be a log of base e, which would be ln of x. Oh, that looks terrible, sorry. ln of x. And again, just to recall, this is what e to the x looks like. It's going to go same idea right here. And it's going to go through that 0.01, but it's also going to go through the 0.1e. That right there is 1e. Well, the flip-flop is true. And that would be the inverse. That would be ln right there. And again, what is next to it can't be, or the domain has to be greater than 0. Okay. Now, you have to, when you go to graph these, you really have to understand specifically how to graph it on Pearson. And I'm going to show you how to do it right now, and then I'm going to show you on Pearson. I looked up a homework problem how to do that. A lot of my pre-calc students were struggling with now on Pearson just how to type it in. So I'll show you how to do it. But really, if you go to graph this, you all know that if you are inside the parent and you have a +3, that means you would shift left 3. And again, your domain would be where x plus 3 is greater than 0. So x has to be greater than -3. So there is a vertical asymptote there at -3. So you've taken what I've drawn up here, which is the ln of x, and you've now shifted it over. And it's going to get really close. And it's going to go over like that. Well, it's kind of terrible, but you really want to understand.
Go up for just a quick second?
Sure. You got it?
Yep. Thank you so much.
All right. No worries. Sorry. So going back to this one, again, your domain is where that next to the ln has to be greater than 0. So that's all I did here. So I knew that I had that asymptote at -3. And I just shifted it left 3 along the asymptote. Same thing for this one, okay? If I'm inside the parent, I'm going to go right 2. Right 2. And again, I like to just set this x minus 2 greater than 0. So x, the picture has to be greater than 2. And that's your asymptote there. So you're going to go to 2, make a little dash. And so that picture way up here now has to shift over. This originally had an asymptote right here at y equals 0, or x equals 0, excuse me. Now it has shifted over. So your graph is going to get very, very tight along here and then shift over. Again, you can put this into Desmos very easily and look at the shift, but you really have to understand that it moved to the right. You will get asked a question on describing the transformation because, you know, they love that stuff. So you look at something like this and you're like, okay, well, what occurred? And if there was a number with the x inside of the x, like if there was a parenthesis like this one up here, you'd say, oh, it went right 2. But if it's just +1 on the outside, that means it went up 1. And then if there's a number outside of the log, remember those are the vertical stretches by a factor of 2. And again, you can type this into Desmos, which I will in a minute, just to show you how to type it in again. So 2, and then go to log. I wish it would just stay log. I'm sure there's a quicker way of doing it, but I just seem to keep going here. There we go, log base A. 2 log of base 2 of x, and then close the parenthesis and then put plus 1. And then you can see where it's it's stretched it a little bit. And it's still hovering over that x equals 0 line, or that's still its asymptote, but it's actually shifted it up a little bit more. And again, you can put all this into Desmos very easily. But they really, they're going to ask you questions about what do these mean, these parts right here. This is vertical stretch by 2, this is going up 1, and they always like to ask that stuff. Okay, this is the one where it's going to ask you to graph both 2x plus 3 and the f of x, okay? And we're going to just work it out real quick algebraically. Then I'll show you how to do it on the actual Pearson application. So real quick, if you are trying to solve for or rewrite 2x plus 3 as a log, this would be, you would just, I don't know if you remember this, but to find the inverse, you switch your x and y and solve for y. So you would say, all right, this is my x and this is my y. And then you can minus 3 over 2 to the y. And then I'm going to rewrite this so that the exponential is on the left. So this would be 2 to the y equals x minus 3. And I'm going to do what I did last class, which is the zoop, and I'm going to write it as a log. So this would be log base 2. That's what I started with, of what I wrapped around, x minus 3 equals y. And that is the inverse. So again, I just switched my x and y. There's my x, there's my y. I subtracted my 3 over. I like to write it so that my exponential is on the left because I always zoop from left to right. So I just put it 2y equals x minus 3, and then I zooped around and wrote log base 2 of x minus 3 equals y. In the next section, we'll actually show you how you can solve these very quickly and find the inverse. But this right there is your inverse. And when you go to graph them, which we will do on Desmos right now, we will graph 2 to the x and then plus 3. And then here we will graph log base 2 base 2 of x minus 3. And I always love to put in y equals x just to see that it's flipping over it, just to make sure it looks pretty good. It does, looks really good. And you can see that shift right there from 2 to the x, it has gone up 3. So it has the new asymptote is at 3, the horizontal. But for this one, there's a vertical asymptote at x equals 3. And you can answer questions about domain and range and all that fun stuff. Now, I wish Pearson was as nice as the graphing that one, but you will have to graph both of these, and I'm going to just really quickly plot the one for you. So let me go 1, 2, 3. And then if x was 0, this would be, the intercept would be at 0, 4. So this graph is going to look like this. I should probably have found a better question, maybe like 2, which would be 7, 2, 7. 2, 1, 2, 3, 4, 5, 6. Oh, I was close. I was off a little bit. There we go. And then this one has now, again, think about x minus 3 has to be greater than 0. So x has to be greater than 3. So you are now right here. You've shifted that way. And it looks like that. And you can, but for me to show you on Pearson how to graph this, because this is the one that a lot of my students were struggling with. So hopefully I wrote down the question that it was. Question, of course I wrote question number 30, but I don't know, it must be on this section here. Jack, my dog is making a lot of noises. It's this one right here, I believe, right? Yes. Let me preview. And I think it actually still makes me graph them. Solving logs. No, you don't want to, that's going to be homework tonight. It's the might be this one. That's what it is. Graphing, finding inverse. There we go. See, I have to watch the video also. It won't let me preview it. Okay, there we go. For the exponential function f and inverse, the inverse of f, analytically and graph both f and f to the -1 of, and then here's the one they gave me, 4 to the x minus 8. And so we could do this one if we have to. So 4 to the x minus 8 would be, you just flip your x and y and solve for y. So you'd have x plus 8 equals 4 to the y. I'm just doing it out on the side right now. So it'd be log base 4 of x plus 8. And I'm going to type that in. Log base. Okay, man. Let's see. Log, does it just not let you do log base? Look at this. I haven't done this in a while. I make myself notes and I haven't done it in a while, so that's my problem. There it is. Log base 4 of x plus 8. Good job, thanks. But let's graph it. Okay, there we go. I wanted to get to the graph. All right, so hopefully you're paying attention because this was very annoying for me. You have to graph both of them, first of all, for this question. So I'm going to graph the one that they gave me, which was 4 to the x minus 8. So you hit the exponential tool. And then it really doesn't matter where you put the point. I just put it here. It's this little box that comes up right here. You have to change the base right here where it says base E to base 4. And then since it was minus 8, that would be a, let's see, horizontal shift over 8. So you would say horizontal shift 8. It's minus 8. See if it actually does it for me. Yeah, shifted over 8. Actually, it should go to the right 8. So what am I doing? There we go. Shift it over again for me. There we go. And then for the logarithmic tool, you choose this one. And again, you put your dot wherever. I don't think it cares. And for this one, you change the base to base 4 again. Oh my gosh. Jack. You're about to die, my little doggy. He's moving my desk all around. And this one, I'm going to say goes left 8. And so you just want to be careful, and then you can obviously check it in Desmos. I think it's, I'm graphing it correctly. So 4 to the x minus 8. Ooh. Oh, yeah, duh. No wonder I'm getting that one wrong. I'm like, what am I doing wrong? And then this one, I shouldn't have said left 8. I should have said vertical shift or horizontal vertical shift down. Sheesh, Sharon. And this one is, there we go, log base 4 of x plus 8. Here we go. I knew that looked terrible. All right, so let me go back to what I had here. Well, of course, I've lost it all. There it is. Okay, so I got to go back on my thing. I know I did this terrible. This one is awful. This one had a vertical shift. I know. Thank you. 0. And then, but why is it not? Let me look. Did I choose the wrong one? I did choose the wrong one again. See, oh, I feel your pain. This is why, Mrs. Setta. Okay, it's this one. Thank you. And you went minus 8. Let's see. There we go. That's so much better. This guy is my logarithmic one. Okay, sorry about that. It's just I've got my crazy dog right now is killing me and he's moving my whole entire desk. So I'm having a problem. But here's what happened. Sorry about that. So let me click save just to make sure. So you answer the question, you solve it analytically. The biggest part is the base is 4 for both of them. So you need to make sure that when you click on here, this one's the exponential, the one that looks like the hook, and you make sure you call it base 4. Well, you actually put your graph wherever and make sure you call it base 4. And then how it shifted minus 8, which means it went down 8. So you write that it had a vertical shift minus 8. So that's this beautiful one right here. And then you would hit this one, which is the logarithmic function. And then you put that it shifted to the left. And so that's what it definitely is going to ask you for. But a lot of my students were hating this one and they were just constantly getting it wrong. So